Let us calculate crystal field stabilization energy of octahedral system. The d orbital splitting in Eg and T2g like this way. Let's consider the two energy ratio are y and x, and the total energy difference will be delta 0. So maximum capacity of electrons 6 in the T2g orbitals multiplied by energy plus similarly 4 multiplied by y equals to multiplied by delta 0 equals to 0, and the total energy will remain the same. So 6x equals to minus 4y, or x by y equals to minus 4 by 6. So the ratio will be x and y will be equals to 4 is to 6. Now consider D4 system, low spin and high spin. Before we calculate the CFSE, one thing to remember, the pairing energy is nothing but the difference between low spin pairing energy minus high spin pairing energy. For the low spin complex, what happens? 4 electrons will be distributed like this way, making a pair as delta 0, which is very high in pairing energy. And what happens in high spin complex? The electrons will be distributed like this, where delta 0 will be less than 3. So CFSE for low spin complex will be equals to all those 4 electrons in the lower orbitals. So in the T2g, so 4 multiplied by 0.4 delta 0 plus the difference between pairing energy will be 1, so P minus 1.6 delta 0 plus P, whereas CFSE in high spin complex will be equals to minus 3 into 0.4 delta 0 plus 0.6 delta 0, which will be equals to minus 1.2 plus 0.6 delta 0 equals to minus 0.6 delta 0. Now let us consider another system. We can calculate the CFSE. D6, first orbital splitting, 6 electron for the low spin, 1, 2, 3, 4, 5, 6, and the high spin 1, 2, 3, 4, 5, and 6. So the difference between the pairing energy will be 3 minus 1 equals to 2. So CFSE for the low spin complex will be equals to 6 multiplied by 0.4 plus 2p, which will be equals to minus 2.4 delta 0 plus 2p. Whereas for the high spin complex, CFSE will be equals to minus 4 electrons multiplied by zero point 0.4 delta 0 plus 2 into 0.6 minus 1.6 plus 1.2 delta 0, resulting minus 0.4 delta 0. All those are assumed to be negative values, which signifies the stabilization. Another system, D7, what happens? For the low spin complex, the 7 electrons will be 1, 2, 3, 4, 5, 6. The last one in the EG orbital. For the high spin, 1, 2, 3, 4, 5, 6, 7. So the difference between the pairing energy 3 minus 2 equals to 1. So the value of P, the sufficient, will be the 1. Thus CFSE low spin equals to 3 electrons minus 3 into 0.4, sorry, 6 electrons delta 0 plus 0.6 delta 0 plus 3 minus 2 as I told P, which means minus 2.4 plus 0.6 delta 0 plus P, which results minus 1.8 delta 0 plus P, and CFSE for high spin will be equals to minus 5 into 0.4 as there are 5 electrons delta 0 plus 2 into 0.6 delta 0, which results minus 2 delta 0 plus 1.2 delta 0 minus 0.8 delta 0. Here we should remember for the low spin delta 0 will be very high than pairing energy. So it will follow the Hund rule and all the electrons primarily occupy the T2G orbital first, then it will go to the EG orbital. But the high spin complex delta 0 is less than P, so it will be distributed like this way, and electrons will follow the rules where all the electron will singly occupied the individual compartment, and then pairing up occurs.